Hi, and welcome to multiple and hierarchical regression. So first I'm going to cover multiple regression. And here we have added more predictors since last week. So last week we just had this part of the equation. This was a simple regression. And now by adding these other predictors here, we are making a multiple regression. So what's really important to understand here is that this equation stays the same, but remembering that each of these beta weights is the unique contribution of the predictor to the equation. So this is a partial correlation that is separating out the effects of the other independent variables. So unlike correlation that counts the variance twice, this model will separate out the variance and attribute what belongs to each variable. So we refer to the beta weight as the slope or the unique contribution of each variable. And it's a weight applied in this linear equation to tell us the importance of the variable to predicting the dependent variable. So the higher the beta weight, the more it's contributing. And you might have some beta weights that are significant and some that are not. So now, once we have multiple predictors, there's one other thing that we need to account for, and that's something called multicollinearity. And regression is very good at looking at variables that are not related to each other. So the equation cannot handle variables that are very highly correlated. And by this, I mean 0.6, 0.7, 0.8. So 0.6 might be okay, but if you have two variables that are highly correlated, meaning they're sharing a lot of variance, you would want to pick one or the other to put into regression, because if you have predictors that are sharing too much variance or have this multicollinearity, it makes the beta weights and the F statistic unstable. So you can tell by looking at something called the VIF, the VIF, or the tolerance, and we'll look at that when we run our regression. So everything's going to be the same from last week in terms of this is your dependent variable. This is your constant where the y-intercept, where the line comes in. But we keep using a line, but technically a multiple regression becomes this multi-dimensional plane, which I cannot draw for you. And then this beta weight is still, for every unit you go over in X, how high do you go up in Y, which is how much is contributing, how important it is, how significant it is. And you still write the regression equation the same way. You write out your dependent variable, your constant, and you write the unstandardized beta weights here out to 3 decimal points. Okay. Now, the other thing that's new here is we're going to include a beta weight table, and I'll show you how to do that. So let's practice with our data set here. So, if you want to get the story on the data set or exactly how I wrote this up, you can always look at my write-up here, because this write-up is mimicking. Now I have 2 write-ups here because we're going to do 2 different things, but this write-up is mimicking what I'm about to do. So, but let's go up here and see how do we run it. So steps to conducting a multiple regression. We're going to go analyze, regression, linear, same as last week. Now our dependent here is current salary, and that's what I got from the write-up below. And then we're going to look at months on job education level, and work experience. These three things. Let me make sure I got them right. Education level, months on job, and work experience. Oops, and age too. Let me add in age. Okay. Now, I'm going to go to statistics. And let me actually check back up here, make sure. All right. So we want to check confidence intervals, descriptives, estimates is already checked for us. And part and partial correlation. I'm also going to check collinearity diagnostics and Durbin-Watson. Durbin-Watson checks for autocorrelation. You could also check for outliers this way through here. We're not going to do that today. Hit OK. Now, we get our descriptives, which will be nice for a table. Here's our correlation table. It's telling me the variables I entered. And remember, and when the method, which is we're using enter here, and my dependent variable is current salary. Okay, so we want this Durbin-Watson to be close to 2. That means we haven't violated the autocorrelation errors. And the first thing we're going to do is we're going to check our R square and our F. So let me take here. So this R square tells us the percent of variance. So we have 43% of the variance of current salary is accounted for by these 4 variables. And this is significant. And I know this from the F value. This is the P value. And we will use this for our degrees of freedom. Now, the regression is the model and residual means error. So if you can remember that, that should help you because it's the same from ANOVA. All right. Now, we look down here. Here's our 4 variables. This is the constant. These are our 4. This is our little b. So it's in the metric of the variables so that the equation works. This is our big B. It looks like this. Now, this is very similar to a correlation, -1 to +1. So we can compare the different variables, right? And right here, I see, and this is my p-value. So I look here. This one is significant. This one comes close, but is not. So the only one that I'm going to interpret is this one, and that's large. And this is my confidence interval. Right, so that's what I'm going to interpret. Now, I'm looking at my VIF, and you want this to stay 1 to 2, and you want this to stay close to 0.9 or 0.8. And what I notice is this is out of the range. And when I look back, I say, oh, okay, work experience and employee age. Those two must be correlated. And let me clear the annotation and go back up and look. Turn it off. Now, if we go back up, let's look. Age and work experience. Okay, right here, this 0.813, that is a problem, right? It's too high. So what I need to do is I need to rerun this without one of these variables. And they're both highly correlated, so they're telling me the same information, but experience is a little more job related than age. So I'm gonna go with that one. So let's rerun this. It's regression. I'm gonna leave everything the same. I'm just gonna take age out. Okay. Now, My R-square value has stayed the same. It's 44%. Everything's significant. And education level has gone up just a slight bit, probably because we're doing a better job with our model. But here you can see everything's 0.9 and everything's 1. So that looks good. So let's write this up. Where to put it? Oh, I'm going to put it down here. Okay, now I'm going to go back and annotate what I'm going to write here. So what we care about here again is the R square, the F, the P, that tells me whether this R square is significant. Here's our degrees of freedom. And then we care about this line here, education level. Okay, now the other important thing to understand is when you make a regression table, and I'm going to change colors so you can see this is different. Your regression table is just going to be this. And you would put an asterisk or a star right next to this. And this would be labeled little b, SE, all of this is italicized, and big B. And then of course at the bottom you would say what this asterisk means. It's significant at what level. And remember, the 0, 0, 0 is always P is less than 0.001. Okay, so let me write it up. In addition to the write-up, I'm not going to write all the words that are already on the write-up in your notes, but just showing you how I got this. I would say the model is significant. R squared equals 0.44 F, and the degrees of freedom are 3,438. My F value equals 113 point, whoops, it's actually 114 because when you round that up, it's going to look like that. My P is less than 0.001, making sure you italicize the R square, the F, and the P. Also, make sure that you superscript that 2 on the R. Okay, so that tells us about the model, and the model allows us to look at the individual predictors. And so all we need to write about is the one that's significant. So the model is all of the variables together, and you will write that in your equation. But when we report significant ones, we would say education was the only variable that significantly predicted current salary, comma, and I'm going to report the big B here equals 0.67. And then what makes that significant is this T value. Now I'm going to go up and get this 438. The residual degrees of freedom is always the one I'm going to use for my T value. And my T value equals 17.92, rounding up. And my P value is less than 0.001. Okay. And the other thing I forgot to say is this is a medium effect for the R square. Okay, now I need to explain it. So it's positive, which means as education increases, so does current salary. Now remember, you want to do a scatter dot of this, and you want to do your beta weight table. Okay, let's look at I'm going to clear my drawings. Go back and let's look how this was written up. So this report contains a regression on 441 employees. I say the test, a multiple regression was conducted. I say what the variables are. You know, did they predict current salary, which indicates they were predictors and current salary is the criterion. I write up the model. Although this F value reflects the one with the 4 variables. And this is a medium effect size. Overall, whoops. The overall model is a significant predictor and accounts for 44% of the variance. So I didn't write that out. That's something important to write. More specifically, the individual level. And here I've put in the little b. You can see the t value is the same. Please see table 1, your regression beta weight table. As employee education level increased, so did their current salary. Your scatter plot, and then the regression equation. Now this one has all 4 variables, but you can see how it's written. And for that is something we did not do. Let me write that up really quick. Okay, so I would say the regression equation is, now my constant's coming from right over here, and it happens to be negative, right here. Minus, and this is actually money, 10,896.357, writing it all the way out. Whoops, I forgot to write independent variable. Current salary is equal to the constant plus, because it's positive, 38.174. And that is once on the job, plus 1586.085, and that is education, plus 42.712 work experience. And you would write all these out, I'm just abbreviating here. But that is how you would do your equation. Okay, and so next we're going to do hierarchical regression. So with a hierarchical regression, we're actually running 2 regressions and comparing them. And we refer to these as blocks. And now we're interested in the R-squared change. And so this R-squared change right here looks at basically the difference in the contribution of new predictors, the difference between model 1 and model 2. And so this is the only new thing that's coming, and that we're just going to be looking at the blocks together. So hierarchical regression is used when we want to know the difference between 2 models. Another term is when we want to know incremental variance, and that means variance above and beyond. So some examples of this would be when personality predictors came out, people said, oh, it's the same as cognitive ability. And hierarchical regression was shown to prove that personality did add incremental variance over cognitive ability, meaning that it contributed something different and unique. And hierarchical regression is used in mediator analysis and moderator analysis. Moderator analysis is how you look for interactions in regression. But it's also used to control variables. So, and what we're going to do here, that's what we're going to do here, is if you want to hold something constant and you put it in the first model, and then you can see what does the second group predict above what you're holding constant. So sometimes like we might want to hold age constant, or we might want to hold socioeconomic status constant. Here we're going to add, we're going to hold age and gender constant. So if you look at our write-up, and this is a separate one. Further, it was suspected that gender and ethnicity may contribute to salary. So these variables were entered first into a hierarchical regression in order to hold their effect constant. Okay, so in model 1, gender and ethnicity were the predictors. And then in model 2, we'll add our 4 work-related variables, although we're actually going to only put in 3 because we now know that this age is got some problems. So let's go here. We're going to analyze regression linear. Now, I'm going to reset everything. We'll start over. But current salary is still our dependent variable. And now we're going to put in, let's see, minority classification, which I believe is a 0 and a 1, and employee and gender. Now, these are dichotomous variables. Let me see if I can go to the variable view. So here we can see 9 is actually labeled as missing. So we just have 0 are actually men and 1 is women. This is labeled incorrectly. And then here we have white and non-white. Okay, so these are dichotomous variables, and remembering that I'll go over how to interpret them. So now we look at statistics. We want our confidence intervals. Here, we definitely want our R-square changed. And let me go back up so you can see where I'm. We want our descriptives. We want our part and partial correlate, and our linearity. We can always check our Durbin-Watson. Continue. Now, this, you'll notice up here, this says block 1 of 1. To do a hierarchical regression, we need 2 blocks. So what I'm going to do is I'm going to hit the next button, and it's going to give me block 2 of 2. And now I'm going to add my 3 variables of interest here and hit OK. So we have our descriptives and we have our correlation matrix. Here it's telling us what's in the first model or block and what's in the second model or block. Now, we're going to have 2 R-squares, one for the first model. Let me put in my title and then annotate. Okay. See if we have enough room for this. Okay, my tolerance and my VIF looks good. Education's correlated with something, but it's not too bad. Okay, so this is the R-square for model 1. Okay, this is the F that tells me that my model 1 is significant, the F and the P, and this will be my degrees of freedom. Now, this is my model 2. I'm going to do it in a different color. And this is the F that tells me model 2 is significant and the degrees of freedom. Okay, so gender and ethnicity account for 24% of the variance of salary, and that's not good. Now, gender, ethnicity, and my 3 variables, so all 5 variables together, account for 50% of the variance. Right? Now, let's look at what the difference is. So these 3 variables by themselves have an R-squared of 0.26. So, and then this is the F. This is the degrees of freedom. and the p-value for r now, and these are all r squared change. And I denote the r squared change with the triangle. The change means. And let me go back and say that the blue is the r square for model 1. And the green is the r square for model 2. Okay. Now, just to be clear, model 1 has gender and ethnicity. Model 2 has 5 variables: gender, ethnicity, months on job, employee age, and education levels. R squared change is the way that we tell only the 3 variables. So this one is only months, oops, I have age in there, but education, I put in the wrong one. I should have put in experience, but I'll go back and redo that. And this is age, but I should have put in experience. Okay, so the other important thing to understand about hierarchical regression is we're only going to interpret from this block, this second block, right? So here's where we're going to pull any numbers about individual predictors. Now, however, your table, excuse me, your table will include both models, and you will separate out model 1 and model 2. Okay. So that's your table. This is where you're going to pull your numbers from. Okay, so let me write this up. All right, so model 1 with gender and ethnicity was significant. R square equals 0.24. F, my degrees of freedom is 2 and 455. And the F equals 72.68. And P is less than 0.001. Okay, so gender and ethnicity contributed 24% of the variance to current salary. Okay, I'm going to say model 2 with gender, ethnicity, months on job, age, and education level was also significant. And then I'm just going to copy this right here and change the numbers. And my R square is 0.50. And my F is 5,452. So I'm just going to change these numbers. And my F value is 91.47. My p-value is the same. All variables contributed 50% of the variance to current salary. Just work-related variables, which are the three, were significant. R-square change. You can look for that triangle in your symbols. And here I'm going to be pulling up from all the everything up here in the red. So my R-square change is 0.26. And oh, I'm going to copy and paste again. Taking out my equals 0.26. My F value is 3,452. And I'm sorry, that was the degrees of freedom. The value is actually 79.06. The p-value is less than 0.001. Okay, so that's how you would write that up. And you can see, again, look in my description in here. Now the numbers are going to be slightly different because I had a different variable in there, but you should get the same you should be able to get the impression. Okay, so then let me get this to line back up the way I had it. Okay. Oh, that's actually not going to line up. Okay, let me clear the drawings so they're not confusing. Okay, so now let's go down and look and interpret the individual variables. I'm looking here. And let's see, we have 1, 2, 3 variables that are significant. So it is ethnicity, gender, and education in the final model, right? And so remember, we're not going to interpret anything significant from here, only in the second model for individual predictors. And so we would write these up. And so in order to do this, let me turn off my annotate and this and insert a heading. Okay, so I might say something like individual predictors that were significant were gender, ethnicity, and education. Gender was a significant predictor of current salary, comma, B is equal to, and this is negative, so negative 0.26. And my t value is, and remember, never report a negative t value, just make it positive. So that would be 6.9 converts to 7.00 equals, oops, sorry, that was it. Forgot to put in my degrees of freedom, which is the degrees of freedom from the last model 452. Oh, I don't know if I can get that line back up again. 452 equals 7. Oh, that's wrong. Hold on. roughly. That's there. Okay. And I'm actually, let me start with the I should start with the biggest one. I started with the biggest one of the demographic ones. Okay, so my T equals 7, and my P is less than 0.001. Okay, I'm going to copy this and put it here again because my first one should have been education level. Was a significant predictor. And the number for that is 0.57, and it's not negative. The degrees of freedom is the same. The t-value is 14.99. The p-value is the same. Okay, but now I need to say what it means. So as education increases, so does current salary. Now, gender was a significant predictor, and it's negative. So remember, if it's negative, it's going to look like this. And we know that men were 0 and women were 1. So as current salary goes up, it tends to be a man. As current salary goes down, it tends to be a woman. So another way to write this would be current salaries were lower for women. Now I'm gonna, okay, yeah, period. Okay, now I'm gonna copy and paste that statement again and just switch this out for ethnicity. And it is a minus 0.12. Degrees of freedom stays the same. My t-value is 3.51. Remember, it's negative, but I'm just going to write it positive. P-value is less than 0.01. Now, to do this again, this also was for white and for non-white. Sorry, my N. Yeah. There we go, white and non-white. All right, so I'd write this. Current salaries were lower for persons of color. Okay. So that is how you would write this. And then the equation is, now here you would write current salary equals, now for this, I am just going to read right from this box right here for the equation, the second model, remember, and just that. So current salary equals negative 5405.139. Whoops, that didn't go anywhere. Okay. Oh, there it is. Minus, because this next one is negative, 2089.541 times ethnicity minus 3530.673 times gender plus 29.80 times months plus 22.727 times age, and then last 1,334.173 education. Right, so that is my equation. Now, to do the table, remember, move away from this. Clear all my drawings and stuff, the annotation. Okay. Remember, to get your APA tables, you're going to go to Course Home, Course Files and Resources, APA table. Now, here is your regression table just for a plain regression, and you'll notice, oh, I'm sorry, I actually told you a little b, but this is a big B. You'll see what it looks like here with your R square down here. Here is a hierarchical one with model 1 and model 2. So you're going to want to copy and paste this and put your numbers in for that. Okay, I hope this is helpful. Please send me any questions you have, and otherwise I will see you in class. Good luck turning this output before class time. Thanks.